Hi, welcome to the final analytical geometry tutorial. Today's tutorial is titled Advanced Cumulative Analytical Geometry. This tutorial is going to cover all of the work that we have done thus far in analytical geometry. Hence, in order to progress on with this one, you need to have gone through the first 5 analytical geometry tutorials. Please note that this is a bit of a tricky section, so you do need to pay careful attention, and I'll say this again, you need to have gone through the first 5 tutorials and understood them well. I want you to get started by having a go at the following exercise. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do had a circle with center 3 and 3 and a tangent touching the circle at point T, x is equal to 5, y is equal to 2. I asked you to give me the equation of the tangent to the circle. Now, the tangent to a circle is a straight line, so it's going to have the form y is equal to mx plus c. Can I calculate the gradient? Which is usually a good point to start. I can't because I've only got one point of the tangent. But I do know that the radius of a circle is always perpendicular to the tangent. So, the radius of the circle, the gradient of the radius is going to be given by y2 minus y1 over x2 minus x1, which is going to give me negative 1 over 2. That means that the gradient of my tangent is going to be given as positive 2. The negative inverse of that, because remember 2 times negative 1 over 2 is equal to negative 1. They're perpendicular to each other. That means that the equation of my tangent now reads y is equal to 2x plus c. To get our c value, we substitute the only point in that we have. That means that 2 is equal to, y is equal to 2x, 2 times 5 plus c. That means that c is equal to 2 minus 10, which is negative 8. So the equation of our tangent reads y is equal to 2x minus 8. Number 2 says that we have a circle with center AB. We have a tangent to the circle at A, 4 and 8. Passing through the y, or rather intersecting with the y-axis at y is equal to 5. I want you to calculate for me the values of a and b. We are going to be using gradient for this. First, we're going to start off by looking at the equation of our tangent. Now, the equation of our tangent is going to be given as, in fact, we don't need to find the entire equation of the tangent. We just need to find the gradient of the tangent. The gradient to the tangent is going to be given as y2 minus y1. So that's going to be 8 minus 5 over x2 minus x1, which is going to give me an answer of 3 over 4. That means that the gradient of my radius is going to be given as negative 4 over 3. Now, if that's the gradient of my radius, to calculate a and b, I'm going to say negative 4 over 3 is the gradient of it, but to get the gradient of the radius, we're going to say y2 minus y1 over x2 minus x1 is equal to the gradient, which is negative 4 over 3. The other bit of information I gave you was I said that the radius is equal to 3 units. Using my distance formula from the center of the circle to A, I'm going to be using A and B, but I know that it's going to come to a radius of 3 units. That means that AB squared, O is the center of the circle, AO squared is going to be given by y2 minus y1 squared plus x2 minus x1 squared is equal to my radius squared. Leave it in this form for now. This is equation 1, this is equation 2. Let's manipulate equation 1. B minus 8 is going to be given as minus 4 over 3 multiplied by A minus 4 to get rid of that denominator. B minus 8 squared, instead of saying B minus 8, I'm going to say negative 4A plus 16 all over 3 squared plus A minus 4 squared is equal to 9. Simplifying this is going to become minus 4A plus 16 squared is going to give me 16A squared. 16 times 16 times negative 4 is going to give me negative 64 times 2 is negative 128A 16 squared, so that's going to be plus 16 squared is equal to 256. All of that over 9 plus A minus 4 squared is going to give me A squared minus 8A plus 16 is equal to 9. Common denominator of 9, that means that 16A squared minus 128A plus 256 plus 9A squared minus 72A plus 16 times 9, which is 144, minus 9 is equal, minus 81 is equal to 0. I took that 9 across, but I also multiplied it by the 9. 16A squared plus 9A squared is going to give me 25A squared minus 128A minus 72A is going to give me minus minus 200A plus 256 plus 144 minus 81 is going to give me plus 319. That's all going to equal 0. Now to solve this one, unfortunately, I'm going to have to use the quadratic formula. A is equal to minus B, which is minus 200, which is positive 400, plus or minus square root of B squared negative 200 squared is equal to 40,000 minus 4A, 4 times 25 is 100, times C is going to be 31,900. 100 times 319 is 31,900. All of that over 2A, which is over 50. If I punch this into a calculator, I'm going to get an answer of, first I'm going to work with the positive, so it's going to be 400 plus square root of 40,000 minus 31,900, all of that over 50, and that's going to give me an answer of 49 over 5, which can be simplified to be 9.8. The other option is going to be 400 minus square root of all of that divided by 50, which is going to give me an answer of 6.2. So I've got two possible A values, 6.2 or 9.8. Both of them are valid. Both of those A values are valid for the coordinates of the center of the circle. Now to get my corresponding B value, I'm going to substitute that A value that I've calculated into one of these equations. Remember that there are two possible B values. The first B value is going to happen when A is equal to 6.2. So that means that B is going to equal negative 4 over 3 multiplied by A, which is 6.2 minus 4, which is 2.2, plus 8, take the 8 across. That is going to give me an answer of negative 4 over 3 multiplied by 2.2 plus 8 is equal to 76 over 15. That means that the one set of coordinates for A and B can possibly be 6.2 for A and B, 76 over 15. The other set of coordinates for A and B are going to be when A is equal to 9.8. So that will be 9.8 minus 4 multiplied by that plus 8 is going to give me an answer of 4 over 15, or, and let's leave it as 4 over 15. So the other possibility is when A has the value 9.8 and B has the coordinates 4 over 15. Both of them are valid. The third one I gave you to do had a circle centered around the origin with diameter AB and point A given as 4, 4. The first thing I asked you to do was to find the equation of the circle. Now in order to find the equation of the circle, remember the standard circle that's centered around the origin, its equation is x squared plus y squared is equal to r squared. This is fine except we don't have r. Substitute that point in to get r squared, which means that that's going to be 16. 4 squared is 16 plus 4 squared is 16 is equal to r squared. That means that r squared is equal to 32. That means that x squared plus y squared is equal to, instead of r squared, it's equal to 32. And that is the equation of our circle. The next thing I asked you to do was to find the length of AB. Now remember, if r squared is equal to 32, it means that r is equal to root 32. Root 32 can be simplified. Remember, 32 is equal to 16 times 2. Square root of 16 is 4. Root 2 stays as root 2. Our radius is 4 root 2. That means the distance AB. Now AB is the diameter, which means that it's twice the length of the radius. That's the radius. The diameter is double that length. which means that AB in simplest third form is equal to 8 root 2. We just doubled that. The next question, number 3, says, does the point, or the third stuff that I asked you to calculate, says, does the point C, which has the coordinates -3 and 6, does this point fall in the circle? Now, in order to do that, we're going to use a little bit of logic. If the distance from the center of the circle to point C, which is somewhere over here, I'm not too sure whether it's in or out the circle, it could be either there or there. The distance from the center of our circle to point C, if that distance is equal to our radius or less than our radius, it means that point C falls in the circle. If the distance from the center of our circle to point C is greater than the radius, it means that point C falls out of the circle. To get the distance from the center of our circle to point C, we're going to use the distance formula. OC from the center of the circle to point C is going to be given as y2 minus y1 squared, which is just 6 minus 0 squared, which is 6 squared, which is 36, plus x2, which is -3, minus x1, which is 0, squared, so that's -3 squared, which is 9. That means that OC is equal to root 45. That means that OC, the distance OC, is equal to 9 goes into 45, 5 times square root of 9 is 3. 3 root 5. OC is equal to 3 root 5. 3 root 5 is equal to 6.7. And our radius is 4 root 2. 4 root 2 is equal to 5.66 or 5.6 or 5.7. That means that point C lies outside the circle due to the fact that OC is greater than the radius. The last one I gave you to do had a circle with center 1, 1. Tangents to the circle AP and AQ touch the circle at points P and Q respectively. I first wanted you to calculate the coordinates of A. Now, in order to calculate the coordinates of A, what is A? A is the point of intersection where AP is equal to AQ. In order to get the coordinates of A, I'm going to need the equations of AP and of AQ. To get the equation of AP, remember it is a tangent to the circle, which means that it is perpendicular to the radius. The equation of the tangent AP, I can't get it just yet because it's of the form y is equal to mx plus c, but we don't have our gradient. We can, however, calculate our gradient. Our gradient of our radius is equal to y2 minus y1 over x2 minus x1, which is going to give me positive 1. That means that the gradient of our tangent is going to be -1, or just negative x. So our equation of AP reads y is equal to -x plus c. To work out c, substitute the point we have in. That means that 3, which is our y value, 3 is equal to -3 plus c. C is equal to 3 plus c, with 3 plus 3, which is equal to 6. That means that the equation of AP reads y is equal to -x plus 6. To get the equation of AQ, I'm going to follow the same process. Firstly, the gradient of our radius at point Q is going to be given as y2 minus y1 over x2 minus x1, which is going to give me an answer of 2 over negative 2, which is negative 1. That means that the gradient of our tangent is equal to positive 1. Gradient of the radius perpendicular to the gradient of the tangent. That means that our tangent reads y is equal to positive 1x plus c. To get c, substitute the point that we have in. That means that 3 is equal to negative 1 plus c. c is equal to 4. That means that AQ has the equation y is equal to negative x. Y is equal to positive x plus 4. And that is the equation of AQ. Now, to get the coordinates of A, it's when this equation is equal to this equation or graph. That means that minus x plus 6 is equal to x plus 4. Take the x across, it becomes minus 2x is equal to 4 minus 6 is minus 2. That means that x is equal to positive 1. That means that the x value of A is 1. To get the corresponding y value, substitute that x is equal to 1 into either of the equations. Y is equal to 1 plus 4, which is 5, or y is equal to negative 1 plus 6, which again is 5. That means that the coordinates of A are x is 1, y is equal to 5. I then asked you to find theta. Now have a look at this closely. Theta is that angle over there. It is going to be very difficult, if not entirely impossible, to work out theta using angle A. But doesn't this form a triangle? A till that point, we don't know what that point is, we don't need to know, but A till that point to there, doesn't that form a triangle? Let me sketch that in red. That forms a triangle. And what do we know about the interior angles of a triangle? They are equal to 180 degrees. So what if I were able to find that angle over there and that angle over there, subtract it from 180, and that would give me theta. To get those angles, I'm going to use m is equal to tan of theta. Firstly, of AP, we know that our gradient is negative 1. That means that negative 1 is equal to tan of theta. That means that theta is equal to the inverse function tan, or second function tan, of negative 1, which is going to give me an answer of negative 45 degrees, or rather 180 degrees minus 45 degrees, which is equal to 135 degrees. That means that that angle is 135 degrees. But we're not looking for that angle, we're looking for that inside angle. Remember, this whole thing is equal to a straight line, which is 180 degrees, which means that that inside angle is 45 degrees. Similarly, for AQ, our gradient of AQ is positive 1. That means that tan theta is equal to 1. That means that theta is equal to 45 degrees. So that is also 45 degrees. That means that these two added together come to 90 degrees. That means that this angle on top here, the theta at the top, or rather let's call that, to avoid confusion, QAP, angle QAP, which is what we're looking for, is equal to 180 degrees minus 45 minus 45, which is equal to 110 degrees. And that brings us to the end of analytical geometry. I hope that you enjoyed it. It does count probably about a third of your maths paper 2, so it is important work. Go through the exercise that I left for you in the workbook, and I look forward to seeing you in the next section of work.